You know, in courtrooms and crime labs all over the world, there's a hidden battle of wits going on every single day. And it's not about fingerprints or DNA, it's about data. We're diving into the super high-stakes game of digital forensics, a real duel between investigators who are trying to uncover the truth and some very savvy criminals who are trying to bury it for good.
And that's really the core of the problem, right? Every single click, every file you save, every message you send, it all leaves behind a digital trace. These are basically the invisible fingerprints of our time, but finding them and then proving what they actually mean, well, that is a super complex and constantly changing puzzle.
So think about it. The digital crime scene today, it isn't a room you can put police tape around. It's a hard drive, it's a phone, it's a server. It's just a mountain of data. And to sort through all that, investigators have this whole arsenal of specialized tools. With so many options, that very first decision they make, that can be the difference between solving the case and it going cold forever.
Now, this isn't just about picking your favorite program. An investigator's choice of tool is often based on what they're familiar with, their training, or, what their agency can afford. But is the tool you know best always the right tool? If you choose wrong, you could miss that one crucial piece of evidence, or just waste precious time you don't have. So the big question is, how do you make the right call when you're under all that pressure?
Well, what if there was a way to turn this from just a gut feeling into a calculated strategic move? That's exactly where researchers are looking, turning to a really fascinating branch of mathematics to give investigators a bit of an edge.
That brings us to game theory. It sounds complicated, but it's basically the science of strategy. It breaks down situations where the result of your choice depends on the choices somebody else makes. The rock, paper, scissors analogy is perfect. You're trying to guess your opponent's move so you can make yours. In digital forensics, the game is picking a tool to maximize your chance of finding evidence, knowing full well the criminal has already made moves to hide it. Okay, let's make this real. Here's an example straight from the research. An investigator needs to do something called file carving. It's basically recovering deleted files. They have two main tools. On one side, you've got Scalpel, which is incredibly thorough. We'll call that the file-sensitive strategy. On the other side, you've got PhotoRec, which is way faster, the time-sensitive strategy. So what do you pick? Do you go for thoroughness or do you go for speed?
So game theory helps us figure this out by calculating what's called the net gain. And that's just the value of the evidence you find minus the cost of the time you spent looking for it. If that net gain is higher for the slow, super thorough approach, then using Scalpel is the absolute best move. It's what's known as a Nash equilibrium, basically a point where if you switched your strategy, you'd only get a worse result. Imagine a big, complex fraud case where you need every single document. Time isn't the main issue. Getting all the evidence is everything. That's when you choose Scalpel.
And here's the flip side. If the math shows the net gain from using the faster tool, PhotoRec, is higher, then that's your winning strategy. Picture this. An investigator raids a location with a bunch of computers. They don't need to find everything right there on site. They just need to find one incriminating thing, and fast, to justify seizing all the hardware for a deeper dive later. In that case, speed is absolutely the winning move. Okay, so the investigator has made their strategic choice. But remember, this is a duel. It's not a one-player game. The opponent gets a move too. And you better believe a sophisticated criminal isn't just going to sit around and let their data be found. Nope, they're going to fight back with something called anti-forensics.
This analogy is perfect. Anti-forensics is the art of fighting back. It's not just as simple as hitting delete. It's about actively hiding, destroying, or even faking digital evidence. The whole goal is to mislead investigators and make their expensive, powerful tools totally useless.
And the playbook they use is, wow, it's deep. Suspects can digitally shred files so they're completely unrecoverable. They can forge timestamps to cook up a fake digital alibi. They can even change a file system's magic number, this key little identifier, to make an entire hard drive look like it's unreadable. Some of these attacks are even designed as traps, like the compression bomb, a file that looks tiny but is engineered to crash the investigator's software the moment it gets scanned.
So this brings us to the ultimate showdown, right? What happens when an investigator's carefully chosen, top-of-the-line tool goes head-to-head with a criminal's carefully laid anti-forensic trap? Can these tools we trust so much actually see through the deception?
Well, to find out, a study did exactly that. Researchers took 4 of the most popular, most respected forensic toolkits on the market. I'm talking about tools used by law enforcement and huge corporations all over the world, and they threw a whole battery of common anti-forensic attacks at them. The results are, well, they're pretty alarming. Just take a look at this scorecard. On the left, you've got the anti-forensic attacks, and across the top, the different tools. Just look at all those failed marks. Against techniques like secure deletion or modifying that magic number we just talked about, every single tool failed. They were completely blind to what was happening, which means they either missed the evidence entirely or were just stopped dead in their tracks.
Let's just pull one of these out because this one is huge. Forging a file's timestamp can create a totally false timeline of events, a perfect digital alibi. So of the 4 top-tier tools they tested, how many do you think could reliably detect that this was happening? 0. A big, fat 0. Not a single one. The tools just collected the misleading evidence and presented it as if it were fact.
And what about those traps, the attacks on the tools themselves? Remember the compression bomb designed to crash the analysis software? How many tools saw that trap coming? You guessed it, 0. Again. This means an investigator's own toolkit could be turned against them, maybe even destroying other evidence on the system as it crashes.
So, what does this all mean? Is digital forensics just broken? Well, not exactly. It's more like a really sobering snapshot of one moment in time in this ongoing technological arms race. For every new forensic technique that gets developed, you can bet a new anti-forensic countermove is being worked on. And the duel just keeps going.
And really, the core takeaway from the research is a pretty stark warning. The authors themselves put it best. Investigators cannot absolutely rely on CFTs, that's computer forensic tools, because they can collect evidence that is not complete and credible. The tools are vital, absolutely, but this research shows they are a long, long way from being perfect.
And that leaves us with one final and really crucial question. In a world where a piece of digital evidence can be the deciding factor between guilt and innocence, what does it mean for justice when the very tools we depend on to find the truth can be so easily fooled? This whole digital duel, it's not just about code and data. It's about the credibility of our entire legal system. And the next move? That's anyone's game.